Welcome back. We are still looking at college algebra. We are doing the second part of 2.1 day 2. Hopefully you grabbed some kind of device where you could use Desmos.com. Okay, this says use a graphing utility to complete the following. Step 1, they want us to graph y equals negative 2x squared plus 10x. So I'm going to go ahead and do that. Remember, when you're entering things in Desmos, you never put in the equals. It's whatever is after the equals. So negative 2x squared plus 10x. So I go ahead, it says sketch the graph. So if I look at this, here's what the graph looks like. I notice that it touches here at 0. It also touches at a 5. It's a graph that is opening downwards. Okay, so I sketched the graph. Now it says to find the x-intercepts. The x-intercepts, those are the x values where your parabola touches or crosses the x-axis. So for part B, your x-intercepts, x touches at 0 and x touches at 5. Now compare them with the solutions of the quadratic equation if I set this equal to 0. So now they want us to use algebra skills to kind of prove it. They want us to have the y as 0. So 0 equals negative 2x squared plus 10x. If I am trying to solve something like this, you always look to see first if they have something in common that I could take out. I can divide out a negative 2x. If I divide negative 2 by negative 2, I get a 1. Here I had 2 x's. If I take 1 out, I'm down to 1. Positive divided by a negative is a negative. 10x divided by 2x is 5. Now what you do to find your zeros? Once you have it factored, you take each piece. The first piece is what you could take out. The second piece is what they had left in parentheses. You take each piece and you set them equal to 0. Now I go ahead and solve. 0 divided by negative 2 is 0. Add 5. 0 plus 5 is 5. So graphically, when I went ahead and graphed on Desmos, I could see that my x-intercepts were located at x equals 0 and x equals 5. When I set the original function equal to 0, factored it, took each piece separately, set it equal to 0 and solved, I ended up with the same values. Okay, here is another one just to make sure that we've got this. So I'm going to go ahead and delete that screen. We want 4x squared plus 25x minus 21. So again, they want us to go ahead and sketch it. So notice there's a really narrow graph, but that's all right, we got this. So if I go ahead and I sketch it, it's a really narrow graph. Okay, so that is part A. Now part B, find the x-intercepts. So I can zoom in on Desmos. What I'm trying to do is find the x-intercepts. I have two x-intercepts. They are the location where your graph crosses the x-axis. So x equals negative 7 and x equals 0.75 or 3/4. Next part, they want us basically to prove it using algebra. If I have 4x squared plus 25x minus 21, they said to set that equal to 0. Okay, I could try to factor it, but knowing that I have such large numbers, I'm going to do the quadratic formula. A, B, and C. A is the number in front of your squared term. B is the number in front of x. C is the number at the end. To see how many solutions we should get from this, I take b squared minus 4 times a times c. If I go ahead and I enter that into the calculator. Okay, so if I have 25, because that's b squared, minus 4 times a is a 4 times c is a negative 21. Underneath the radical, I have 961. This is a positive number, so I should end up with two solutions. So x equals negative b, so it's negative 25, plus or minus the square root of 961 all over 2 times a. A is a 4, 2 times 4 is 8. Now if I look, the square root of 961 is perfect. It's 31. So this, I'm going to actually grab a separate sheet of paper here. What I actually have, if I simplify this, I have x equals negative 25 plus or minus. The square root of 961 we said was 31 all over 8. Now to find the two answers, remember you add the two values on the top and then divide by 8. Negative 25 plus 31 equals 6. 6 divided by 8 is 0.75. Now to find your other solution, you subtract the numbers on the top and divide by 8. Negative 25 minus 31 is a negative 56. Divided by 8, I get negative 7. So those are my two solutions. If you look at the two solutions we found by graphing, you'll notice that they are the same thing. So when you set a quadratic equal to 0 and you solve, what you're actually finding are your zeros, the location where the parabola touches or crosses the x-axis. All right, the back page. If a is greater than 0, that means that your parabola opens upwards. If it opens upwards, you have a minimum value. That minimum value is located at the opposite of b over 2 times a. That's the x value. That's where you can find the minimum. The minimum height is whatever y is. So once you know x, you'd have to put it back into the original function. Now, if your a value is less than 0, meaning that's negative. If it's negative, it opens upwards. So your vertex is a maximum value. That maximum value can be found using x equals the opposite of b over 2 times a. That's the x value. Now, if you want to find the maximum height, the maximum value, you need to fill x into the original function, okay? Here are some story problems. A helicopter is rising at a rate of 32 feet per second. At a height of 128 feet, the pilot drops a pair of binoculars. After t seconds, the binoculars have this as their height. When will the binoculars reach the ground? Okay, so this represents the height of the binoculars. If you want to know when they hit the ground, you set this thing equal to 0. Negative 16t squared plus 32t plus 128. When will they hit the ground? That means when will this equal 0? Now I could go ahead, try to simplify it, try to factor it, do all those things. In fact, I'm going to try. Is 128 divisible by negative 16? Heck yeah! Okay, if you can divide everything by a common term all the way across, we can go ahead and do that. Let's say you did not notice that. You could always go to the quadratic formula, and a could have been negative 16, b could have been 32, c could have been 128. So if you're watching and you're saying, oh, what if I didn't know that I could divide by negative 16? Totally fine. You could have done the quadratic and you just would have been dealing with bigger numbers. If you recognize this, check this out. Negative cancels a negative, 16 cancels 16, so I have t squared. Positive divided by a negative is a negative. 32 divided by 16 is 2. That's connected to a t. Positive 128 divided by negative 16 is negative 8. 0 divided by negative 16 is 0. So here is my function. I can factor this. Two numbers that multiply to negative 8 and add to a negative 2. Well, that's going to be negative 4, positive 2. Because negative 8 times 2 is, negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So all I did here is factor. Now to solve for t, t is the time in seconds. You take each group separately, set it equal to 0 and solve. Here I would add 4, so t equals 4 seconds. Here I would minus 2, so t equals negative 2 seconds. Now obviously I have two answers here. One of them doesn't even make any sense. When we look at the problem, a pilot dropped binoculars. After how many seconds will the binoculars hit the ground? Well, it cannot hit the ground a negative amount of seconds. So your answer is 4 seconds. After the pilot drops the binoculars, 4 seconds later, the binoculars would hit the ground. Okay, let's look at another problem. The revenue is the amount of money you're collecting. So the revenue from producing and selling X units of a product is given by 3x minus 0.1x squared. Find the revenue from producing and selling 2 units. Well, here's my revenue function. X is the units. So if I am looking for the revenue from 2 units, you simply just go ahead and change the X's to a 2. Revenue for 2 units, X represents units, so I replace the X's with a 2. If I take 3 times 2 minus 0.1 times 2 squared, the revenue, if you have 2 units, revenue is money, so 5.6, that's $5.60. That's how much money you would collect if you were producing and selling 2 items for whatever it is that you're making. Find the number of units needed to be produced and sold in order to maximize. If you are looking at maximizing or minimizing, what you're looking at is your vertex. This is a parabola. It's opening downwards because I have a power of 2. Your value in front of your squared term is negative. Okay, so if I want to find out how many units, that's the X value. Maximums or minimums, it's the opposite of B over 2 times A. A is the number in front of your squared term. It is negative 0.1. B is the number in front of your variable. It's a 3. C is your constant. In this case, we do not have one. If I want to find the number of units, the X, in order to maximize, opposite of B, negative 3, over 2 times A. If I take 2 times negative 0.1, I get negative 0.2. If you divide the 2, negative 3 divided by negative 0.2, negative divided by a negative is a positive. 3 divided by 0.2 is 15. That is units. So if you want to maximize your revenue, bring in the most amount of money possible, you would need 15 units. What is the maximum revenue? So this is how many units you need. To find out the maximum revenue, you fill that X value in to your revenue function. So revenue at 15 units is 3 times 15 minus 0.1 times 15 squared. Now remember, revenue is how much money you collect. It's not your profit. Your profit is how much you actually get to put in your pocket after you paid the bills. So this is how much money you would collect. The maximum revenue would be $22.50. So again, if you are looking for maximums or minimums, to find the X value, it's the opposite of B over 2 times A. If you want to know when something's going to hit the ground or the value is going to 0, you set the equation equal to 0 and solve using factoring or the quadratic formula. Okay, 2 more examples just to make sure we've got it. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by this function. This is the function we're going to use. F of X, this is the height of the baseball in feet. X is the horizontal distance from home plate. So how far is the ball from home plate? F of X is how high is the ball above the ground. What is the maximum height reached by the baseball? So we have to first identify X equals the opposite of B over 2 times A because we're looking for a maximum. This is not going to be the maximum height. This is going to be when. What is the horizontal distance from home plate? When will it hit that maximum height? A, the number in front of the square term, negative 0.0032. B, the value in front of X is an unwritten 1. C, the value at the end is 3. X equals the opposite of B, so it's negative 1, over 2 times A. 2 times negative 0.0032 is negative 0.0064. If I take negative 1 divided by negative 0.0064, I have 156.25. That's X. X is the horizontal distance in feet. So that's where it's going to hit its maximum height. To find the maximum height, you need to find f of x because f of x is the height. This says what is the maximum height. So now I need to take this value and plug it into the original. So f of 156.25, it would look like this. Negative 0.0032 times 156.25 quantity squared plus 156.25 plus 3. I'm going to go ahead and plug that in. Negative 0.0032 times 156.25 quantity squared plus 156.25 plus 3, the maximum height. So f of 156.25 equals 81.125 feet. That is the highest that the baseball will go. That occurs 156.25 feet from home plate. Okay, let's look at another question. Last one for the day. A soft drink manufacturer has daily production costs of 70,000 minus 120 times x plus 0.055x squared. C is the total cost in dollars. X is the number of units produced. Approximately what number of units, so we're looking for x because x is the number of units. Approximately what number of units needs to be produced to yield a minimum cost. Maximums and minimums. It's x equals the opposite of b over 2 times a because maximums and minimums occur at a vertex. A, the value in front of my squared term, 0.055. B, the number in front of x, negative 120. C, my constant, 70,000. So if I want to solve for x, the minimum would be the opposite of b. Opposite of a negative 120 is a positive 120. All over 2 times a. 0.055 times 2 is 0.11. So x equals 120 divided by 0.11. It is approximately, if you're going ahead and calculating this with me, holy smokes, look at that. So we're going to have to round it to the nearest whole unit because you can't make 0.9 of a soft drink. Okay, so if I go ahead and look at this, it's approximately 1,091 units. Because this tells me it's 1,090.9, so we would round to the nearest unit, 1,091 units. That, my friends, is the second part of 2.1. Tomorrow is a worksheet workday where you will just be looking at application problems. Hope you had a great day. Talk to you soon.